Good morning, students. Let's continue with chapter thermal properties of matter. So far, in this chapter, we have seen heat and the phenomena which are related to heat, and now let us see the heat transfer. Heat is transferred from one point of the medium to another point of the medium in three ways. The first one is known as the conduction. The second one is known as the convection, and the third one is known as the radiation. These are the three ways in which heat is get transferred from one point to another point. The heat is transferred from one point to another point in a solid is in the form of conduction. For fluids, what are the fluids? The fluids are liquid and gases. In liquid and gases, the heat is conducted by the process known as convection, and the third one, for which material is not required, even in vacuum, the heat is conducted from one point to another point. That is the radiation. In radiation, heat is travel in the form of electromagnetic waves, which is the fastest mode of heat transfer. This is the fastest mode of heat transfer. The heat transfer at a rate of 3 into 10 raised to 8 meter per second with the velocity of electromagnetic waves. And this conduction is the slowest mode of heat transfer, and this conduction is fast mode as compared to conduction of heat transfer. So in these three forms, heat is get conducted from one point to another point. In solid, heat is conducted in the form of conduction. In fluid, heat is conducted in the form of convection. And if we are not having a medium, then if heat is conducted, that is the radiation. Now let us see one by one the heat transfer. The first mode of heat transfer is conduction. Now let us see what is this conduction. As I have already stated that in solid heat is conducted from one point of the medium to another point. Now let us consider I was having a solid rod. This is the solid rod. This is one end and this is another end of the solid rod. Initially, let us consider the solid rod is having molecules. These are the molecules. This P, Q, R, and S, these are the molecules of the solid rod. These molecules, all these molecules are at same temperature, and so the amplitude of vibration of all these molecules is same. These molecules, they are vibrate with the same amplitude because they carry the same temperature, same energy. Now suppose with the help of an external burner we provide heat to end A, and now this end become hot. As comparatively this hot end, this end is cold end. When heat is supplied to this hot end, then the molecules which are present at this hot end, they receive heat. And when these molecules receive heat, what happens? Naturally, they start vibrating with larger amplitude. So the initial amplitude of vibration, now it changes, and this molecule now start vibrating with large amplitude. And when this molecule start vibrating with large amplitude, naturally it get collide on the neighboring molecules. This is neighboring molecule B. On this molecule B, this molecule A is get collide. In collision, it transfer heat to this molecule. It transfer heat to this molecule, and that's why its amplitude of vibration that get increased. Naturally, as this molecule is now vibrate with large amplitude, it collide on its neighboring molecule. This is the neighboring molecule, then its amplitude is also go on increasing. In this way, heat is transferred from one end of rod to the other, and this is known as conduction. In conduction, heat conduct from one end of rod to another. You have noticed one thing, that the molecules, they are not moving from this hot end to the cold end. The molecule P is remain there at this position. The molecule Q is remain here at this position. The molecule R is remain at this position. These molecules, they doesn't change their positions. Now the conduction is defined as, now let's see the definition of this conduction. This conduction is a process. Conduction, what is conduction? This conduction is a process. What happens in this process? In this process, heat flows from where to where? From hot end to cold end of a solid body without any net bodily movement. Without any net bodily movement of particles of the body. So this is the definition of conduction. What is conduction? Conduction is a process by which heat flows from hot end to cold end of a solid body without any net bodily movement of particles of the body. You have observed that the metals are good thermal conductors. The metals are the good thermal conductors. They carry heat from one point to another point easily in small time. And the wood, air, they are the bad conductors, which are also known as the insulators of thermal conductivity. So the all metals, they are the thermal conductors, and all insulators, they are like wood, air, brick, they are the thermal insulators. They oppose resistance to the flow of heat, and from this we will see the applications of this thermal conductivity. The first application of thermal conductivity is in the cooking utensils, which are made up of metals, and their handles, they are provided with handles with the insulators. The cooking pots, they 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 are made up with metals, and their handles, they are made up with wood or ebonite. The second application is the walls of cold storage are thick, which are made up of the bricks. The bricks, they are the uh, thermal insulators, and that's why the heat is not conducted from one point to another point. And the third application is to prevent ice to prevent ice from melting. To prevent ice from melting, it is wrapped in gunny bags. The ice is wrapped in gunny bags so that the ice does not get melted. Now let us see the next one, that is the coefficient of thermal conductivity. For this purpose, let us consider we are having a solid cube whose all faces are equal. This solid cube is having 6 faces. This is face A and this is face B. The face A and the face B, they are opposite faces. They are opposite to one another. Suppose initially the faces are having the same temperature, and now this face A is heated, so its temperature becomes T1, and heat is get conducted from face E to face B, and the temperature of face B is also get increased, it become T. Here this temperature of this face A is greater than the temperature of the phase B. We say that this phase is hot, and compared to it, this phase is cold. Then the heat is conducted. The amount of heat Q is conducted from hot phase to the cold phase, the quantity of heat which is conducted from hot phase to cold phase, that depend on several factors. What is this Q? Q is the quantity of heat flows from hot end to cold end. This quantity of heat which flows from hot end to cold end, that depend on various factors. Let us see one by one which are the factors. As I already stated that conduction is a process in which the molecules, individual molecules, they get collide on their neighbors. So if the area of cross section of this cube is smaller, then naturally it consists less number of atoms, and if this area of cross section of this cube is get increased, then the number of molecules which are present here, that number get increased, and that's why large number of molecules, they get collide on their neighbors, and that's why the quantity of heat which flows from hot end to the cold end, that is directly proportional to area of cross section of the cube. The second parameter on which this heat depends is the temperature difference between two phases. If this temperature T1 is very much greater than the temperature T2, then the heat is transferred from this hot end to cold end, that amount is also get increased. So this Q is directly proportional to the temperature difference between the two phases. And the third parameter on which heat depends, that is the time interval for which the heat flows. If the time interval, the time duration is get increased, then the amount of heat which is conducted from hot end to cold end, that also get increased. And the last factor on which this heat conduct depend is the distance between the two phases. If these two phases are widely separated, if the distance between them is large, then the amount of heat which flows from the hot end to cold end, that get decreased. And if these two phases, they are close to one another, then the heat which is conducted from the hot phase to cold phase, that is get increased. So this Q is inversely proportional to X. So what we get, this Q is directly proportional to area of cross section, is directly proportional to the temperature difference, is directly proportional to the time duration, and is inversely proportional to the distance. The constant of proportionality, this constant of proportionality is K, and this is known as the coefficient of thermal conductivity. We get the equation for coefficient of for the heat Q is equal to K into A into T1 minus T2 into T divided by X, where this K is the coefficient of thermal conductivity. Now let us rearrange this equation for the coefficient of thermal conductivity K. What we get? we get the new equation. This K is equal to Q into X divided by T1 minus T2 into T into A. Now let us consider, we are having all the faces of that cube is of 1 meter unity. Then naturally the area of cross section of each face is 1 meter square. Again let us consider that the temperature difference between two faces is 1 degree Celsius or 1 degree Kelvin, and the last thing, the time duration T is equal to 1 second. We consider all these terms unity. This X is 1, this T1 minus T2 is 1, this T is 1, this area is 1. Then what we get? Then we get K is equal to Q. Or we may say that the coefficient of thermal conductivity K is equal to Q. What is this Q? This Q is the quantity of heat. What is this Q? This Q is the quantity of heat which flows for 1 second. For how much time in duration this heat flows? It flows for 1 second. From where to here? Between the opposite faces of cube whose sides are of 1 meter, and the faces, they are kept at a temperature difference of 1 degree Celsius. From this we define the coefficient of thermal conductivity. The coefficient of thermal conductivity of a material is defined as the quantity of heat, the quantity of heat that flows in 1 second, between the opposite faces of cube, of side 1 meter, the faces being kept at a temperature difference of 1 degree Celsius or of 1 degree Kelvin. And from this formula we can define the coefficient of thermal conductivity. The coefficient of thermal conductivity of a material is defined as the quantity of heat that flows in 1 second between the opposite faces of cube of side 1 meter, the faces being kept at temperature difference of 1 degree Celsius. Now let us see the SI unit of this thermal conductivity. What is the SI unit of this cube? The SI unit of Q is joule. This X is in meter and this area is in meter square. So meter by meter square means per meter. This time per second, and this T1 minus T2, that is the temperature difference per degree Kelvin. So joule, second inverse, meter inverse, Kelvin inverse, this is the SI unit of coefficient of thermal conductivity. Now let us again revise the same equation for Q. What is Q? Q is K, on which factor is depend? The area of cross section, the time interval, and the temperature difference, and is inversely proportional to the distance. So this Q is equal to this much. Now differentiating this equation, what we get? dq by dt is equal to, now let's rearrange this equation first. This Q by T, this T is transferred to this side. What we get? Q by T is equal to K into A into T1 minus T2 divided by X. And now differentiate this equation. What we get? dq by dt is equal to minus K into A dt by dx, where this dt by dx is the temperature gradient. Temperature gradient means the fall of temperature with distance. So it is T2 minus T1 divided by dx, the change in distance. If the change in distance, these are the positions, they are positions or the coordinates, then what is this here? Px is equal to x2 minus x1. So, and this x2 minus x1 is x. Here we rearrange the term, and that's why we taken here the sign negative. The coefficient of thermal conductivity is also defined by taking this area of cross section as unity is 1 meter square, this temperature gradient as unity. Then what we get? Then we get this K is equal to dq by dt. What is this K? What is this K? If we rearrange this equation, then this K is equal to minus dq by dt. What is this dq by dt? This dq by dt is rate of flow of heat. What is it? It is rate of flow of heat. This K is equal to minus dq by dt divided by A into dt by dx. One correction here, this dt, this is the time rate, this t is the time and this t is the temperature. So this K is equal to dq by dt divided by A times dt by dx. And if this area of cross section is unity, the temperature gradient is unity, then we can define the coefficient of thermal conductivity. The coefficient of thermal conductivity of a material is defined is defined as the rate of flow of heat per unit area per unit temperature gradient when the heat flow is at right angles to the faces of a thin parallel sided slab of material. So this is the alternative definition of coefficient of thermal conductivity. The coefficient of thermal conductivity of a material is defined as the rate of heat flow. What is it? It is the rate of flow of heat per unit area per unit temperature gradient when the heat flow is at right angle to the faces of thin parallel slides of material. This is about the coefficient of thermal conductivity. We again we again see the equation or this Q. What is Q? Q is equal to K times A into T1 minus T2 into T divided by X. And lastly, let us see the thermal resistance. This thermal resistance is denoted by RT. The thermal resistance is denoted by RT. This equation is rearranged. We get Q divided by T is equal to K into A into T1 minus T2 divided by X. This dQ by T is the time rate of heat flow, and this is denoted by P conduction. This Q by T, this is the time rate of heat flow. So the time rate of heat flow, the rate of heat flow, how much heat is flows from one point to another point. This is the time rate of heat flow. To understand the concept of thermal resistance, let us see the electrical resistance. For that, we have to know the formula, the Ohm's law. V is equal to I into R. This R is equal to V divided by I. What is this V? V is the potential difference between ends of conductor. And what is this I? This I is rate of flow of charge. At what rate the current flow? Similarly, the thermal resistance is RT, and this RT is equal to, instead of this potential difference, the temperature difference between ends of conductor, between ends of conductor divided by rate of flow of, instead of charge, heat. At what rate that heat flows, and this rate of flow of heat is P conduction, that is Q upon T, and this temperature difference is T1 minus T2, and from this we say that this RT is equal to T1 minus T2 divided by P conduction. Now rearranging this equation for this P conduction, this P conduction or Q upon T is equal to K into T1 minus T2 divided by X. What is that equation? P conduction is equal to K A, this P conduction is Ka T1 minus T2 divided by X. So this T1 minus T2 divided by P conduction. Now rearranging this equation, this T1 minus T2 divided by this P conduction is equal to what? Is equal to X into X divided by K by A, and this T1 minus T2 divided by P conduction is nothing but the thermal resistance. So this thermal resistance RT is equal to X divided by K times A. K times this thermal resistance RT is equal to X divided by K times A. So this is about the thermal conductivity and the thermal resistance. Thank you. We will stop here.